Hello YouTube. In this video we're going to be continuing our discussion of graphing frequency distributions, but particularly in this video we're going to be discussing how to construct an ogive. Okay, so that is, as you can see up here on the top left, we say ogive is spelled O-G-I-V-E, so ogive. Looks like Ogives, but it's certainly not. So another name for an ogive, as a matter of fact, is a cumulative frequency distribution. So the first thing I want to do is actually tie this into my last two videos, which concern themselves with graphing histograms, which were bar graphs, which dealt with the frequency of data in certain classes, and frequency polygons, which also concern themselves with frequency of data in certain classes, but specifically at class midpoints. In this video, however, you notice on the table on our right here, I am going to point this out because I know that I have some people tune into this video and not my previous two videos. But what you'll see here is a list of data that has been grouped. Okay, this is quantitative data, or interval and ratio level of measurement. But this represents, say, the high temperatures recorded in all 50 states and how the data is distributed. So that being said, you'll notice here, just like with histograms, we are using class boundary information. Okay, so class boundary information is necessary in this. And also you'll notice that we're not listing the frequency of each class, but actually, as a matter of fact, we want the cumulative frequency. Just know, if you're being asked to construct an ogive and you're given the frequencies, you're going to have to go and find the cumulative frequencies on your own. Okay. In this case, they've been given because I want to make this video as concise as possible. So let's go ahead and proceed with what we need here, which is, when you're making a graph, you need your x and y axes. Okay, so I mentioned, a lot like our histogram video, we are graphing frequencies on our y-axis. So we want to label this. We say frequency, and we can also use the lowercase letter f or script f. And then down here we're going to write temperatures, or temps to be concise about it, and we're doing this in degrees Fahrenheit because that doesn't make a lot of sense. Sorry, kind of biased. I like the metric system. But now down here on the x-axis, when it comes to making a frequency distribution or a cumulative frequency distribution in ogive, we want to use our class boundary information, not class limit, not class midpoint, but class boundary. So we say our lowest lower class boundary was 99.5, and of course this goes up to now 104.5. Our next class boundary is 109.5, and we have 114.5. I'm going to proceed to put all of these on here and try to talk at the same time. What a task. 124.5. But you'll notice that the width of each class in this case is 5, and of course we could calculate this by subtracting the boundaries of each class. But we have these on here. Okay, so now the important thing to recall is this. When it comes to why do we make ogives in the first place, they are very convenient when trying to say how many data values fall at or below a certain level. That is, what if I wanted to ask this question? I say, well, okay, so of all the 50 states, how many of them had a high temperature of, say, 125 or below? And so we say 125, or say 124 or below. We say 124 occurred right here. Maybe I shouldn't put the arrow on it, but 124 is right here on our distribution. So we say, 124 or below, that's like 48 of our states, which means that only 2 of them had a high temperature above 124. But that would be good information to know, especially since these cumulative frequencies, we're going to be kind of translating them later on to relative frequencies. That is saying, well, 48, that's 48 out of a total of 50, which is 0.96, which helps us with probabilities. But we say, look, this is in what we call the 96th percentile, this temperature. But that being said, one thing I do want to mention is this. I want to consider 2 questions here, and they deal with the first class. But I say, okay, if this was the distribution of our data, I would ask this question first. How many states had a high temperature of 104.5 or below? Okay. Now recall, the cumulative frequency for a class is like saying, up until now, we've counted up this many things. And so in this case, in the first class, we're saying by the time we got to the end of the first class, or this 104.5, we say, well, then we've counted up 2 states. Then to answer this question, how many states had a high temperature of 104.5 or below? The answer would be certainly 2. The reason why I'm leading in with this question is because my next question is this. How many states had a high temperature of 99.5 or below? Now, the fact of the matter is this was a lower class boundary on the lowest class. So it's kind of like saying that was like our starting point. And so if my question is, how many states up until that point, had a high temperature of 99.5 or below, we could say then 0. So the important thing is this: when you're making a cumulative frequency graph, and I have people mess this up, students that is, and like adults make mistakes too, and so do teachers. Oh my goodness! But just know that when you're making this graph, an ogive always starts at its lowest class boundary at a frequency of 0. So I wanted to point this out before we do anything. Also this, on our x-axis, we need to put a squiggly here to show that we jump from 0 up to 99.5. So now let's talk about our y-axis. Okay, our y-axis. We do go up to a total of 50 here. We say 50 states, and of course this gets a letter. We say n. N is the total number of data, and of course if we add up all the frequencies, we add up all the occurrences or all the data, it should be the total number of data there. But we're going to have to go up to a height of 50, and so that being said, I think it'd be entirely appropriate to go maybe by 10. So we say 10, 20, 30, 40. I'm not labeling all these, or notice I say 50. Now you notice I made 50 a little bit bigger than the rest of those, and I'll label it and I'll say, dear audience, I think you need to be able to figure out the rest of these on your own. But this being said, let's go ahead and get started. So we say 99.5, we just started, we haven't counted up any frequencies yet, we're at a height of 0. But by the time we get to 104.5, which was the end of our first class, we have now counted up a total of our frequencies of 2. So 2 would be about a fifth of 10, it'd be about right here. We say by the time we get up to 109.5 though, which is the end of our second class, we've now counted up 10 total things. So we say 109.5, we're at about a height of 10. 114.5, which is the end of our third class, we've now counted up a total of 28 things. So we say 114.5, we got 20, 28 to be about right there. 119.5, the end of our fourth class, we say 41 is our height, 41. And we say the end of our fifth class, 124.5, we're at a height of 48, so nearly the top, 48. And then the last two here, I think increased by 1, so 48, 49. I'm going to try to make this look as slight as possible. And then our job will be to go back and connect these with a straight line between each consecutive set of points. The straight line, the purpose it serves is just to kind of go to show slope and the rate at which it's increasing. But you'll notice here in this, maybe we'll switch colors up a little bit here, but in this graph, or cumulative frequency distribution, you know that things increase very quickly in the middle. Okay. The reason why is because we had a lot of things occur in the middle. We had a lot of states with high temperatures in the middle. So of course it's going to increase drastically during those green circled intervals over here. These classes, 109.5 up to basically 124.5. Most states were in there. And of course if we were to make a distribution of this, this is a rough kind of like whatever. But it would look something like this. I think we made a histogram in previous videos. But basically, we're saying it was approximately normally distributed. So approximately normally distributed things, that is things, frequencies in which, or distributions in which frequencies occur most often here in the middle, and then kind of tail off on the ends there, we say are approximately normally distributed or bell-shaped things. Okay, so an ogive that has a frequency distribution that is normally or approximately normally distributed tends to increase drastically here in the middle. Okay, so yes, this is very good at saying things like, hey, how many states had a high temperature of 119.5 or below? We could say very easily, well then, about, somewhere above 40. And you can see 119.5 or below, we say 141 was actually that. Or sorry, 41 was actually the height. So, but yeah, that's how you make an ogive.